This is a second video of the diffusion tensor imaging addition to NeuroGuide's program called the NeuroNavigator. This is the demo patient who was struck in the right parietal region with a bat. He's paralyzed on the left, does not shave the left side of his face, and does not write on the left side of the paper, has what's called spatial neglect. And you can see the electrical potential as deviant from normal, and the z-scores for the electrical potential are down here in the scale. Now I'm going to remove the scalp. And you can see now the diffusion tensor imaging bundles, which is all of the bundles that are listed here. And those are all the bundles in the Catania de Schotten Atlas. We can move through the skull with the axial plane. And we can also look at just the z-score deviations from normal. Now this one, that was the z-scores. This one is all of the bundles. And I'm going to move up so you can see that in greater detail. And I'm going to remove the head model. See the cerebellum bundles. Now we're going to go back to the z-scores only. I've set the z-scores here in the lower coordinate here scale, so I'll go show them all. But what you can see in this scale is the right parietal region, and the right hemisphere in general is hypercoherent, and there's a large asymmetry in the cerebellum between the left and the right cerebellum. We can move the slice up and down, and zoom in a bit more if we wish. And I'm going to go to the volume view, and we'll zoom in to these fiber bundles. And I can put a coronal and a sagittal slice in there if I wish. But now we can view these amazing fiber bundles. Take a look at the cerebellum. I'm going to remove the axial slice so we just have the fiber bundles. So too close up, I'm going to come back out with the wheel of my mouse so you can see this asymmetry of the cerebellum and the deviation from normal in the right parietal region. And these fiber tracks, these are colored depending on the magnitude of the EEG coherence or connectivity, both functional and effective connectivity. I can look at lag coherence and other connectivity measures. So I straighten it out. I'm going to look at the phase differences. These are the z-score phase differences. And you can see the blue means they're very short phase differences, and the other compensatory parts of the brain, which are actually left hemisphere is healthy, are red, although you can see this one long frontal occipital fasciculus is also deviant from normal. And I can also look at information flow. This is the magnitude of information flow. And what you see here is the right hemisphere has very low information flow. That's why it's blue. More information flow in the compensatory left hemisphere. We can add the scalp model back so you can see where things are a little bit, and the head model. I'll bring the head down. Get rid of the scalp and evaluate information flow some more. You can select and deselect the various diffusion tensor imaging bundles and just focus on particular ones if you wish. Right now I'm showing them all. I'm going to go back to coherence and make sure I do. There's coherence. And I'm going to get rid of the head model. And now this will be available in the NeuroGuide demo, so people can play around with this and learn more about various aspects of the brain. And then, of course, add the current source densities from the cortex itself. For example, I can add the cortex here. I can make that cortex a little more transparent. And it's always helpful to have the slices, because then you can navigate around the brain. You can put in different planes as you navigate. And evaluate these parts of the brain that have been injured in this individual. So this is a visualization tool that's very powerful and useful for the evaluation of patients such as this one. So thank you for watching, and we'll be developing more of these tools in the future.